All right, begun the recording. Excellent. Welcome to our afternoon session on making Desmos animations. The most fun part of Desmos. You'll enjoy this quite a bit. Now, this is a tool, in my opinion, that's more for teachers than students in a lot of ways. I think especially some of the simulations we'll do today are things you could have students do. And I'll illustrate one way in which you can do that in a way that you can help out, which I think will be great. But ultimately, I think this comes down to a tool for helping create visuals for your students, and visuals that you can animate and make move that are easy to answer questions like, all right, but what happens if we throw our projectile at a 40-degree angle instead of a 30-degree angle? Or what happens if we throw it twice as fast? All of these tools in Desmos allow for that to happen more quickly. So let's begin. Here is, well, I won't be doing much with PowerPoint or Google Slides here, but a little bit of introduction to start us off. Here's our game plan together. We're making animations, and these are the four I have in mind, and I am cautiously optimistic that we will have time for all four. And if not, we'll get through at least the first three. And again, just like this morning, my goal is not expertise, but familiarity, enough that you feel confident to try some more on your own and play around. Because ultimately, especially with this, which is sort of pseudo programming, you learn best by trying it not working, you getting frustrated, and then you realize, oh, I've typed a minus sign instead of a plus sign here, and then feeling like you're in charge, like you're on top of the world after you figure that out. That's how this works. We'll do some guided animations together with these four. And these should highlight a lot of, I think, the key tools and the key things, at least that I think about when I'm thinking about, all right, I want to animate something. How do I go about doing it? A lot of the key ideas will be illustrated with these. Same group norms as this morning. I'll give you a chance just to read those on your own right here. All right, we're going to go ahead and head to the next slide. The one thing I want to be clear about before we get started is sort of what Desmos is and is not when making animations. You can animate lots and lots and lots and lots of things in Desmos, and pretty much anything you'd want to animate for intro physics, Desmos is a great tool for it. That said, it is not a programming language. It is not something where if you have Newton's second law and the acceleration equation, you can't use numerical methods to find approximate solutions. So we're not going to be doing any sort of approximating things, no Runge-Kutta methods with orbits or anything. If you're familiar with anything along those lines, this is not the tool for you if that's what you're interested in doing. Something like VPython or VPython's what I've got in mind is the tool for you to make that happen. And there are others, but that said, those are a bit more complicated, and Desmos is pick up and play, and it's something that you could easily have students do also. That said, Desmos does have a beta version of iterative computations that would allow you to do some of those more advanced methods. And you can, if you copy paste, get into that tool, but since it is still being beta tested, I didn't want to talk about it here. Also, I have only looked at it for about a total of 10 minutes, so I didn't feel like that was the best use of our time. With that, let's go ahead and get started. And the way I'd like to do this is I would like to make a Desmos activity which will be your workspace for the day, and it will allow me to see what the group is doing. And I haven't made this activity yet because I thought it would be a good chance to remind you how that works from this morning and to show what it looks like. And it'll be very quick to make too. So I'm going to make a new activity for our class. We are going to call this making animations. Create new activity. And I'm going to add a graphing calculator screen. And this is going to be the screen for our buggy collision. I'm going to add a second graphing calculator screen. This one's going to be for our projectile. I'm going to add a third screen. This one's going to be for our simple harmonic motion. And let's see, I want that to be graphing calculator. And a fourth graphing calculator screen, which will be our uniform circular motion. And maybe I want to add one more screen that I should have put at the beginning with a note that says, we will use the next 4 screens today. And that's how quick and easy it is to throw together a simple activity like this. I mean, obviously something like hard sort is going to be more involved, but if you just want to do a simple activity, this is all you need to do. And we will publish it. And I will assign it to our class from this morning. And if you are new to this to the afternoon session, I'm going to give you a link to join our class from this morning. And here is the link to join our class. Or you can go to student.desmos.com and type in that 6-letter code. Once you get into the class, you should see the assignment that I just made. All right, and let's go ahead. And I'm going to just quickly make sure that we are all there, 27 of us, which is not everyone in the Zoom yet, but this is the activity. All right, so let's go ahead. And if you want to head to the buggy crash. So if you're not familiar with this activity, the buggy crash is when you get 2 of those little tumble buggies, which are little motorized cars that move at a constant speed. You get them to move it, you get 2 of them, one that moves at a faster speed than the other. You have students measure the speed of each, and then you set them a fixed distance apart to head toward each other, and you have the students predict when they will collide. And this morning, we talked a little bit about how you could use Desmos as a way to find a graphical solution to that problem. Graph the linear equations of motion, find the point of intersection. We're going to now animate that activity together. And we're going to start there because constant velocity motion will highlight just the basics of animations, and having 2 things there is more fun than 1. I will not be using, I'm going to move this screen to my dual screen here, but I just want to grab the calculator. So I just want to go to desmos.com. Usually when I'm making these, I just go straight to the graphing calculator, and that's where I make them. And so I'm going to name this CV_buggy for constant velocity buggies. All right, let's begin. The primary thing that we need to animate anything is a time slider. So I'm going to say t equals 0. Enter. And this will give us a slider. Time for us usually starts at 0. Usually our reference frame is such that we're not looking at times before I started my stopwatch. And so you're going to go click on your bounds, make 0 your first time, and whatever you want your final time to be, however long you want it to go before it resets. That's up to you. I'm going to choose a really big number like 100. And so now my time can run from 0 to 100 seconds. Sometimes it's useful. This won't be necessary in a simple program like this, but if you're getting more involved, it's helpful to have a note above your variable to say that T is time measured in seconds. The units are especially useful to have somewhere. And what does the equation of motion for a constant velocity look like? It looks something like x equals vt plus x0. And I'm going to need sliders for the two variables on the right that haven't been defined yet. So now that I've added those, I can add the sliders. V is the speed of my buggy. Let's say it moves forward at a speed of 0.25 meters per second or 25 centimeters per second. And let's say my buggy starts at position 1. And this would be the equation of motion to describe a buggy that starts at position 1, moving 1/4 meters per second. X is one of those special reserve variables like we talked about this morning. So I'm actually going to rename this so that it's just the position of the buggy at time t. I'm going to call this A for buggy A. I'm also going to rename this initial position so that it's the initial position for buggy A, because we're going to have a buggy A and a buggy B. I'm going to rename this V, VA, for the velocity of buggy A. I need to go back down here too and give myself the initial position for A. This sort of back and forth thinking with subscripts happens a lot for me when I'm animating, because I'll realize something I wanted to do for one object, I want to do it for another object too, so I've got to go back and make the subscripts different for each object I want to make. And so A here is for buggy A, and buggy A and buggy B will each have, in general, a different position, a different starting position, a different velocity, but they do share the same clock. So I don't need to make a TA and a TB. They do share the same stopwatch. And we already have enough to animate buggy A right here. We just need to draw it somewhere. I'm going to choose to put buggy A, we're gonna have it move left to right because X is a horizontal position. And I'm gonna put it up at position 2. So I'm gonna say the Y position for buggy A, oh, hello. The Y position, Y underscore A, equals 2. It doesn't matter where, just somewhere where it looks nice. And it's not going to change. It's going to stay at Y position 2. I'm going to use the point particle model for my buggy, which means I'm going to approximate my buggy as a single point in space. And so I'm going to use capital A to name my buggy, equals B, nope, and it will be represented as an ordered pair in our space. So, and it's at position X sub A, comma, Y sub A, close parentheses. And this is where our buggy starts. And I'm going to label it buggy A. But you do that by checking the label button and then typing in whatever label you'd like to label it. And this indeed is a buggy that starts at X position 1 at time t0. And I set it off the axis so we could see it a bit better. And now to get it to move, we just need to press play to move forward in time. And your buggy will move to the right. if that animation was too fast for you, it was for me, you have control over the animation speed. To control the animation speed, this little back and forth arrow has your animation properties. So it's below the play button. You grab your animation arrow and you can choose how the time slider loops. It can either go forward from 0 to 100 and then back from 100 to 0. That's the default setting. I find for my animations, I tend to prefer this setting, which after it goes from 0 to 100, it restarts back at 0 to 100 again. And so rather than watching the buggy move backward in time, it just restarts the simulation. So this is the one that I find the most helpful. You can choose just to play through it once or to play on forever. The play on forever means you don't have an end to your animation. But I'm going to choose again 0 to 100, but that was too fast. So I'm going to slow that down to maybe 0.2 times that initial speed. And I press play and my buggy crawls along at a constant speed to the right. I'm going to pause, leave the screen up here, and let you take a look at what's there, and then see if there are any questions right now, because this is essentially the core of everything we will be doing today. Can you re-explain the purpose of YA and A? I absolutely can, and I think do that best by using the YA slider. So YA is just, if I could choose to have the buggy be on the origin, and that'd be totally fine. Sometimes though, I find it helpful to offset it a little bit. So I know it's going to be moving left to right. That's what that's what this line is doing. And this is just my offset. How offset do I want it to be from the axis? And then this is actually making this point here. So if I turn off that point, it goes away. The label stays there, but the point goes away. So A is to actually make that point particle, which I am using to model my buggy. And so this is actually a point. Its position on our graph is X sub A, Y sub A. And Y sub A is this constant value, which offset me off of the horizontal axis. And then X sub A is this formula up here, which is moving me forward in time because of the time slider. Can you replace the dot with an image? You you definitely can. And that's what makes this so fun. And so let's go ahead and do that. I'm going to Google tumble buggy. And one's going to pop up. I'm going to choose this one because it's pointing to the left and my buggy was pointing to the left. I'm going to save this image off of Google. And so buggy, it's going to save to my downloads file. So buggy, I want to call this buggy A in particular, don't I? Buggy A, save. I now have this image file. I can go back into my graph and add an image using the plus sign here. So plus, add an image, grab that buggy that I just downloaded. It's in my downloads folder, buggy A, there it is. Right now, that's too big for me, so I have the option to change up the properties. I'm going to make its width and height instead of 10, I'm going to make them both 1. There we go, that's a little smaller. And the center position, rather than be at 0, 0, I'm just going to put it at A. Now its position there is at A, which is that point that moves forward. And it should now move my little buggy. I'm going to make it a little bit bigger. Let's do 3 and 3. There we go. If I press play, my little buggy drives forward. So yes, you definitely can do this with an image. You just make sure your center is whatever animated point you have. And that's all you need to do is make sure the center is the animated point you had. Questions in the chat on how you slow down. I'll just hover my mouse at that point for a minute and leave it there. It's the arrows right beneath the play button on your time slider. So again, if you're looking to slow down or speed up your animation, it's the arrows underneath your time slider that allows you to do that. And you can see with my mouse hovered over there, that's called the animation properties. What are the image formats allowed? I don't know off the top of my head, but I've never had an issue. Any image I've ever uploaded has worked. I'm sure if I do a quick Google search, Desmos allowed image format. So I know I definitely have done JPEGs and PNGs. I've probably done, I think you can put good GIFs in there too. All right, the quick Google search isn't helping, but most image file formats are supported. I've got one person whose animation is going up and down, I think I saw. Is that right? I see that somewhere. I seem to be losing it now.
Yeah, no, it's me, Meg. I'm got all the same, I'm looking at all the same numbers.
Is your ordered pair, does it have X in the second spot instead of the first spot, or whatever you have your time variable attached to?
That's exactly the same time.
Yeah, what I would imagine whatever's in this point has to have it, probably has a T in it somewhere if it's moving vertically.
It looks exactly the same, but I'll keep trying.
All right. Yeah, I don't know right now. I can look at, in a second, I can look at it in the teacher side too and see what you got. Does it mean you have a surfer on your traveling wave? You can totally have a surfer on your traveling wave. That's exactly what that means. Let's see, question higher up. How did you get the label box to show up in part 7? So the label box is automatically there and you have to check it. Like it should always be there if you have an ordered pair. If I just want an ordered pair at 3-3, I can see as soon as I type it, it gives me the option to check label right away. So that automatically pops up with an ordered pair. There's questions on color changes. Yes, you can change colors. Color changes, you click on your gear first. That's your editing ability. And then the point right now is blue. If you want it purple or orange or black or whatever, you can. I will point out a few other things in this edit feature while we're here. I'll remind you how I got there, and then we'll talk about what's there. So the gear is how we edit labels and points. And we click on the dot. You can change the size of your point to be however big you want it to be. You can change the font. This A is the font size. It's just a scale factor. And then you can also angle things, put the angle in radians there that you want to angle it at. And this compass rose may be the most important part for animations. It says on where relative to the point do you want the label? So right now the label is to the right. If I want the label below the buggy, this compass rose will allow me to put it down lower. If I want it to the left there, if I want it sort of up and to the left there, you have control over where you want your label. I want it to be blue because I've got the blue buggy. So yeah, the point A is where the color is for the label. And you do that with the gear. And again, you have control over font size and location too. Oh, Amy, that's a good point. Maybe, Meg, we're pressing play on Y. If I press play on Y, my buggy is going to go up also, because that's changing the Y button. So when we're pressing play, when I press play specifically on the T slider, that's going to move us forward in time. How do we insert the image? I also saw a sorry there. Don't apologize for questions. That's what we're here for. How do we get the image? That's plus button, add item, and then the image button. So adding the image, you go to the plus to add things, and then the image is right there. All right. If we're doing a buggy crash, that means we need two buggies. So I'm going to repeat everything that we have above, but I'm going to use subscript B for buggy B. So the position underscore B equals V underscore B T plus X underscore 0 B. And I have a new velocity and a new initial position, and it asks if I want sliders, and I sure do want sliders for those. So if I scroll down here, maybe the velocity of buggy B is fast, maybe it's a bit slower, but it's going to the left. So it's negative because it's going to the left, 0.1, so 10 centimeters per second to the left. And its initial X position is, let's do 7 to the right. And now all I need is, I'm going to choose the same Y offset for each. And so I'm actually going to go back and change YA's name since it now belongs to both buggy A and buggy B. I'm going to change it to Y offset. This will be the same Y offset for each. I need to go change it in the point A also. And there we go. So I've renamed YA as Y offset since it will belong to both. You could also say YB equals YA as another way to do it, you bet. And anyways, I want my point B to be at X position B, comma, Y underscore offset. And I'm going to make that a red point because tumble buggies come in blue and red. And I'm going to make a label to the top right. And that label is going to be buggy B. Now, if I press play on my time slider, I should have them go toward each other. They do, and buggy A is going faster than buggy B. I'm going to leave that there for a second, let you look, let people get caught up, and ask questions. And while I leave that screen, I'm going to find an image for a red buggy to add for buggy.
To get to the formatting options for the button, the buggy B button, to make
the point here?
Yeah.
Yeah, if you go to the gear for edit list and click on that, you'll see that the red icon next to B changes to be a solid circle. Now when you click on that, you should get all of your options. Right.
Thank you.
You bet. Other questions? Other things? Or other things I need to repeat because I know I kind of went through some of that fast. One question on why did I use the offset? That's a preference thing for me. If I'm having things move from left to right, I just find that it's a little bit easier to see if it's off the axis a little bit. If you want to put it right on at the height y equals 0 and put it on the horizontal axis, go for it. There's nothing wrong with doing that. I like the offset is the only reason I did it. Other questions?
I get a note here of using a slider for Y offset. Maybe I just typed it in funny.
Any variable will by default be a slider.
Yeah.
We'll just choose not to press the play button on the Y offset slider because that'll make things go up and down.
Okay.
Yeah, but any
over
constant value is by
Got it.
default a slider in Desmos.
Okay. So it's there. I just don't see it on your screen. So I thought I typed it something wrong and it appeared.
Oh yeah, no, I've
Okay,
got
it's there.
my Y offset goes from -10 to +10. I've got the slider option too. Is there a way to duplicate an image? You got to add it again. Yeah, you can't duplicate the images. You scroll down? I sure can scroll down. You bet. I'm also going to add the buggy image. So if you want to watch that process again of adding an image, I'm going to do it right now. So we're going to go to the add item. I'm going to choose an image. And the image I'm going to choose is this red buggy that I also found on Google and probably don't have the rights to use here, but will anyways. I'm going to make it the same. Let's say I think 2 by 2 might be the right width and height for them. Yeah, 3 by 3 seemed a bit big. Let's do 2 by 2. And I want to move Buggy B's center to point B. Yes, if you scale height or width by a negative number, it'll flip along the X or Y axis. And so if you want to use the same buggy and flip it, you can put in a negative width and it should invert it. That's right. So if you want them to look like they're going toward each other but want to use the same picture, you can use a negative. So let me show that. Here, if I put in a negative width for my red buggy, it turns around. If I put in a negative height, it'll flip across the horizontal axis. So you can flip your images with negative widths and heights. Nice find, Jeff. You can rotate images. That there's a nice angle feature for changing rotations too. Yeah, the angle works as well. So cool things. And I also think that this is a nice way. This, I think, would be a great activity for students. I haven't done it with students, but I do think it'd be a great activity with students if you do the tumble buggy crash to begin with. Because I think it really does a nice job of relating the mathematical model in the left side to the motion and the animation they're seeing in the graph on the right. And if they measured the speed of their buggies accurately, it should predict when and where they'll crash, right? So if we run our play button on this now, they're going toward each other, they're going toward each other, they're going toward each other, they passed through each other, we missed it, but I've got a slider so I can just try and slide them back to their point of intersection, which is right around there. I'm seeing this is happening at time t equals 17, and I'm seeing position A is 5¼ meters. If I scroll down to X position for B, it's also right around 5¼ meters. So this animation would give them then the predictive power to know 17 seconds later, they're going to meet at position 5.25 meters. Why is it almost 20 seconds long? It doesn't happen that long in the classroom, right? I space them out several meters apart, which we normally don't do in the classroom. But you could set up your mathematical models, watch them digitally crash, come up with a prediction that way, and then go ahead and test it with the actual buggies, linking the simulation back and your model back to reality. This also, if you choose to do the buggy crash as a more open-ended challenge, this type of thinking is usually how students go about doing it first in the beginning of the school year. Usually they're asking questions like, all right, where's each buggy after 1 second? Where's each buggy the next second? Where's each buggy the next second? And this leverages that iterative thinking that students already do by letting them just move the time slider forward each second themselves. Let's see, an error on defining XB in more than one place. My guess is somewhere, I can check out what you got, but you probably have XB equals on 2 different lines. And if I had to guess even further, my guess is your initial XB position, you're missing the 0 here. That would be a guess, but what that means is you have X sub B equals in 2 places somewhere in your animation. All right, I'm going to pause for another, I don't know, 15 seconds here. Can you talk a bit about how much you have the students do and how much you have pre-populated with an activity like this? So I can talk about what I think. I have not had students do animations with Desmos. I have strictly so far used this as a tool for me to animate things that I want to show them that I can't do with a static image drawn on a board. So that's the only time I've used it so far. Now, with an activity like this, how much would be pre-populated, how much wouldn't be? I think if I were having students do this, I don't think I'd have much pre-populated. And that really comes from my own experience of when I've been in classes which try to teach me programming things and they give you some preset code. Usually I find like the one line that I need to change and don't pay any attention to the rest of the lines around it. And I don't really learn anything about what the program's doing. And so I don't think there'd be much value in just having all this set and have them change some sliders around. If you're going to do this with students, I think that they should be the ones typing it in. Now, if you want to use this to animate some things, I think that's fine too, but I wouldn't have students do it then. So I think the value for them is writing out the mathematical model with variables, figuring out the values they need, and then seeing if it works. And some of the anger with that, I think when it doesn't work is good learning for programming and that sort of computational thinking. Other questions? I think we're getting close to ready to move on to the projectile. But other questions before we do? If you give me some feedback in the chat, you can use either as a public message or a direct message to me. Are you feeling ready to move on to projectiles, or we need a little more time here?
I have another question.
Yeah.
If I wanted to demo this but not have the kids' eyes glaze, my less mathematical students' eyes glaze over, is there a way to hide box,
Absolutely.
boxes?
And
or just put them lower down on the list?
That's what I was going to address after questions. I'm glad you asked it. Your mind was right where I wanted it to be. And I do. Anytime I'm making a simulation, I hide all the math they don't need to see. The way you do that is I'm going to click on spot 2 here because I want a folder to appear right below the time slider. You go to plus and you add a folder. So now I can see line 3 has a folder, which I'm going to call stuff I want to hide from students so they aren't scared. All right, so that's your goal. Then you make a folder, and then for object 4 here, for example, I click and drag it up to line 3. Now this lives in the folder. And I know that it lives in the folder because of this very light gray vertical bar that connects them. And yes, all students would open that folder first. You're absolutely right. But that gets them curious about the math, right? Maybe in a perfect world. Anyways, in an activity, you can hide things from students that they can't click on it. But if you're just making a graph, you put it in a folder. Anyways, I'm going to click and drag each object to barely overlap with the line above it. And in doing so, I'm seeing this light gray vertical bar appear. And that means each item here is living in this folder now. And if I click on this drop down arrow, everything in that folder is invisible. And if I click it again, it opens the folder back up. So I'm going to go ahead and do that with, well, let's see, I'm going to put all of A, I think, in one folder. So I'm going to call this folder Buggy A. And so all the stuff associated with Buggy A, I put in this folder and then arrow. And now I can't see anything about Buggy A, even though it's still there. If you missed how I did that, I'm back to the exact same process with Buggy B. I'm going to add an item. The item I'm going to add is a folder. I'm going to name this folder, I'll click and drag it right here, to be Buggy B. And everything for B, I'm going to click and overlap it with the item above it. And this gray vertical bar is telling me now all of these items associated with Buggy B live in that folder that I named Buggy B. I can click on the arrow to hide it, and now the left bar looks much cleaner than it did before. And it's more organized. Yes, it does look much cleaner. I agree. And if you are a better person than I am, you might be making folders as you go and keeping things organized as you go. Or if you're more like me, you will create chaos on the page and then later go back and say, ooh, I'd better organize this a little bit before moving on, so I remember what things are later. And yes, that is also true, Andrea, thanks for pointing that out, is with things in a folder, you can turn whole folders on or off with a press of the circle button. So I can turn everything associated with Buggy B off with the press of this folder. And then I can turn everything with Buggy B back on there. So yes, much less cognitive load, that's right. If I'm trying to illustrate something with my animations, all of the math is going in a folder because I don't want them looking at that math, I want them thinking about the physics behind the animation. That's exactly right. All right, crew, other questions? And let me know feedback on, let's do other questions first.
I figured out how to make a folder earlier, but do you know if there's a way, like, let's say that you wanted to have a third object on here, and you didn't want to go through the process of writing all those things out again. Is there a way to just copy a whole folder and then go in and change the parameter, like the variable names?
The answer is maybe, but I think you can only copy a line at a time. If someone knows better, let me know, but I think you can only copy one line at a time. So I can't copy a whole folder, but I can go into Buggy B, copy that formula, and then paste it again and change the B's to C's. So you can do a line at a time, but you can't do full folders. Other questions? Comments, answers, concerns, hopes, fears, desires.
I was just thinking that you could, in addition to animating the buggies, you could also animate a position graph, so that they could see the position graph as the buggies move. You absolutely can.
Yeah, so if you wanted to do something like, let's say, let's do Buggy A's position graph in the background. So that's going to be, let's just do X Now you can't use XA again because that just means the value of where Buggy A is presently. But you can do XA, let's call it XA graph, equals VA times T naught plus XA0, or X0A. Now let's think about why I chose the names I did for a second. I chose these two, T0 and XA graph, are the variables plotted on this axis, on this graph. And so I couldn't just do T because T is already a specific value from the slider. It's only the number 0. But T naught here can represent the whole horizontal axis. Then here I couldn't do XA for the same reason. XA is just the one point where Buggy A is at my time T. But XA graph can represent all of the positions. And if I want to animate the graph, now I'm going to use my domain restrictions. So I know that I'm going to want TA or T naught to be bigger than 0, because I'm not going to have a negative time. And I want it to be less than or equal to my T slider. And so this domain restriction says the variable T0 that's in this equation will graph my position time graph starting at 0 and only go up to my present time T. And if I press play, we'll watch that graph grow as Buggy A moves forward. And the reason the graph is growing is because its upper bound is T, which is our time that moves higher and higher as we go on. So yes, you can absolutely plot graphs that evolve in time to relate the motion to the graph that's there. Could you use the squiggly parentheses to limit the graph from 0? Yep. So yeah, Jennifer, that's exactly right. You were in the same. Your brain was in the same place mine was. That's exactly right. It makes my brain hurt that the horizontal axis is position for the buggies, but not time for the graph. Yes, that is the one downside if you're going to do it that way. How did you get the less than or equal to? I'll type it in the chat here, but if you just type one symbol then the other, so if you do less than and then an equal to symbol, it'll automatically correct or become less than or equal to. All right, crew. Yeah, so you're having lots of fun with it. It's so much fun. The animations are so much fun, and the principles aren't super challenging. If you know what the position is going to look like, you use that knowledge and have a time slider. All right. Other questions? All right, crew. Let's do a projectile. And in our projectile, what's going to be new for us, we'll have 2D motion, so that's one thing. Oh, so yeah, if we want to turn off the graph, that is what, thank you, Frank, for saying that, because I wanted to mention this y-axis, if we're not graphing anything, is kind of in the way. And you can just go to the wrench, and I don't want the y-axis. And I don't really think I want a grid either. And now my picture is just an X timeline. I wouldn't do that if I had the graph like this, because now the graph looks like it's missing context. But turning that graph off, now you can just see the buggies and the number line that they're on. And so when you're making animations, it is helpful sometimes to turn off certain portions of the grid or axes, depending on what you're animating. All right. Let's do a projectile. New blank graph. Projectile. All right. For making an animation, we know we're going to need a time slider. We start there. We put our time slider there. What do we do next? We're doing a projectile. That's what we need. We need some equations of motion. So let's see. I know that I'm going to want a value for little g. Maybe let's make it 9.8. I know I'm going to want, what else am I going to want? I'm going to want maybe an initial speed and an initial angle, an initial height. So those are maybe the parameters I want. So initial speed, maybe it's 30 meters per second. An initial angle, remember I'm not going to use theta because theta is the default angle. But you can use phi for your initial angle, or phi 0. You could have theta 0 too. The 0 makes it a number again. Maybe 40 degrees. And since I want it in degrees, I need to go to my wrench and make things in degree mode. If you run into issues later, this is probably where your issue, this is the first place to check, is make sure you're in degree mode, which is under the wrench. Yeah, and Marco, different colored number line, are you just saying like draw in a horizontal line somewhere else? Is that what you're saying there?
Yep.
Excellent. So yeah, you could do something like y equals 2 and make your own track and then change its color to be red or green or orange. So if you want to make your own track, you can just put a horizontal line in for your track for the last one. All right, and then initial height, y0 maybe we're jumping it from 40 units in the air. So these are my initial parameters. I'm going to add a note to remind myself of this. This is sort of what you need for a projectile, right? You need to throw it with a certain speed at a certain angle from a certain height. Is there a way you could put the offset below the x-axis and see the displacement graph grow above it? Yeah, you totally could. You definitely could, and that'd be a nice way to do it, I think. And if we have time, we can go around and mess around with that constant velocity buggy some more to make it look a bit prettier and add in that graph in some way like that. I think we could do that. All right, and in fact, rather than a note, I might make this a folder actually and call it initial parameters and put all of those things in there. Now, this is a folder I probably would keep open, but a folder nonetheless. All right. Now, my projectile has an x and a y equation of motion. The x equation of motion, well, actually, let's do this first. Let's split up our velocity into components. Initial velocity components. Initial velocity, its x component is going to be, I'm going to name that V0x. That's going to be equal to V0, let's see, cosine of phi0. That should give me the x component of the initial velocity. If I want to add in the y component, V0y equal to V0 sine of E0. There we go. X and Y components, just use the built-in sine and cosine features. And now that we have the X and Y components of that angled initial velocity, we are set to set up our equations of motion. I'm going to write myself a little note. That's what we're going to do. I use the quotation marks to get this into note mode this time. And we'll write out our equations to describe the motion. The
Remember
X,
that
Yeah,
you
go
may
ahead.
need to set it in degrees if you haven't already.
Yes. Yes, I did mention that. We'll mention it again. Make sure you're in degree mode. If you're not getting these numbers for your components, it's probably because you're in radians and not in degrees. You bet. All right. Horizontal motion for a projectile is constant velocity. So let's call this X. F for final, I guess we'll do. Or maybe X1. I like X1. Equals, I'm just not going to do X because it'll give me a graph instead of a point. X1, let's call it, let's see, it starts at X. Okay, it starts at 0. So 0 plus VT, and that's V 0x times T. So take your initial position, which we didn't name, but we could give it an initial position. Did we name an initial position? No, we didn't. Let's do it up here. Initial X position, let's call it 0. All right. So there's our X position. And I decided to name the initial X position 0. You could, I guess, in general, change that if you wanted. And then I used the X component of the velocity we computed earlier and our T from our time slider. Y1 will make that the final position. Its initial position is Y0 plus V underscore 0 Y times T plus 1/2. And I made G a positive value because I always do that in my class. So this will be times negative G times T squared. And we can see right now that X1 and Y1 are equal to our initial position parameters, which is what we expect because time is equal to 0 right now. And so it should be that. And we can make our projectile right now just a point. So let's call it P for projectile or P for point. And we're going to put it at X1, comma, Y1. Unlike in our last example, both X1 and Y1 in that ordered pair depend on our time slider T. And so this is going to move in both the X and Y direction instead of just the X direction. Now, I made these numbers much bigger than the default scale. So I'm going to need to click and drag. I'm going to bring my 0 sort of down here in the bottom left corner. And I don't know how tall this thing's going to get, but it starts off 40 meters in the air. Let's do 70. If I need to make changes to that, we can. And let's see, how far is it going to get? I don't know, maybe not. If it gets more than 15, we'll make some changes. But there it is. I'm going to label it projectile. You don't have to label it if you don't want to. Actually, I'm going to label it with whee because it's going to move. Okay. That's all we need for our projectile. We press play on our time slider now. Oh, it went fast and much further than I thought. So let's go, I don't know, 50 out here. Oh, it's even further than that. How far? I don't know. It went far. Let's change the timing too. So go back to our animation properties here and real slow, as slow as it lets me. 0.05 I think is what I want. Let's watch it again, starting from 0. All right, there we go. And it's off. .05 might have been too slow. You can also see we're getting much further than I thought in the horizontal range. Let's make it 200. There we go. And we're flying. I'll make the initial parameters go away so you can see everything else as this moves. let's make that speed a little faster. All right. So to make our projectile, to recap the thought process here is we're going to need initial parameters. And so we put those all into a folder, and this is something I can change for, you know, any projectile problem I wanted. These are the things we can change. And once we set it in motion with these parameters, everything's defined by that, right? And so we come up with our breaking things up into components. The horizontal motion is constant velocity. The vertical motion is an acceleration with an or uniformly accelerated motion with an acceleration of -g. And if I put my point P at x1 and y1, where both x1 and y1 move forward in time, then we're golden. We're in good shape. And of course, if you want to make, instead of a point, if you want to put a baseball there, you just grab an image of a baseball off the internet, upload it, and then have the center of your baseball follow that point. All right, I'm going to pause for questions here with our projectile. Yeah, really easy to show your projections along the x-axis. You bet, let's add that in. I like that suggestion. We can add in, or I'm gonna do it this way too. There's a few different ways you can do this. Actually, I'll demonstrate both ways that I'm thinking right now. One way you could do this is call this I'm gonna call this P underscore X, so subscript X equals this ordered pair. You could make it just x1, comma 0. And now that point down below is the shadow of your projectile along the x-axis. And if we press play, we can watch that crawl forward at a constant speed. Now we can do the same thing with our Y layer. I'm going to show a different way to do that one. Still P subscript Y. And instead of at Y1, what you could do is do 0, comma, capital P, period, Y. And period Y means go to the point P and then grab the Y coordinate of that point. And so P dot Y will grab the Y coordinate of the point P. So these are two different ways to get projections. If we press play, we can watch both of those now. Seeing some questions, is there a way to save, a way a student can save off their work into a saved Desmos graph from the activity? Are you asking, can you take something you make in the activity and then just save it as a graph that you have in the graphing calculator? Is that the question?
Yeah, essentially, because you know, you have your folder when you're in your normal account. If a student was to create this, you know, these activities can expire and they wanted to save it off for a portfolio or otherwise, is there a way to export what they did in one of those activities?
I don't know the answer to that. I've never tried to do that one way or another. Does anyone have any experience with that? You can still get into the archive activity, that's true. It is still there, but it's not the same as having it in your saved list of graphs. I totally get that.
They can sort of do it in the Desmos graph and then copy that URL into, I think you can do it. You can paste it into the activity.
So you go in the other direction,
have
them.
I just tried that. And if you go and look at mine, it didn't work. So you can see the link to my graph in the teacher view, but it won't actually paste in because I did try. That's okay. I didn't mean to take up class.
Yeah, no, you're good. There was a question on, can we use a parametric equation to show the trajectory? The answer is, you betcha. We totally can. We can do X. If we're going to do that, though, we do need to make some edits to this. We need to make X1 a function of a different variable, which I'm going to call T0. Actually, I'm going to call it t. I'm going to change our time parameter to t0. So the time parameter is now t0, and x1 and y1 are both functions of some variable t. I'm going to turn off their graphs. And so if you want the parametric equation, you make your equations of motion functions of time like this. And then your point is going to be x1 of your time t0 and y1 of your time t0. And so that's how you're going to recover what we did before. But what this will allow us to do is plot the whole parametric equation. And so if we want to plot the whole thing, we can now get an ordered pair that says x1 of t, comma, y1 of t, and it will show the whole parametric equation from 0 up through, let's say, t0. If we let t0 play forward a bit, we'll follow the trajectory. So yes, you totally can do that. And it's pretty slick, but let me recap what changes we made. We changed our time parameter to t0. And the reason we did that is we wanted to define our equations of motion as functions of time t. And then we plugged in our t0 value into those functions to get the point. And this ordered pair y1 of t, or x1 of t, y1 of t, running from 0 to t0, gives us the parametric equation from 0 to t0. So yes, you can totally 100% do that. And I'll leave this up so that you can look at it a little bit longer, ask questions, with the reminder that our time slider now says t subscript 0. So we'll pause, let the dust settle here.
Joe, do you think you can share these final versions with us?
Yeah, totally.
Mine's not working, and I'm not going to try to have you debug it for me like on the fly, but I do want to try to figure out what's wrong with it.
Yeah, you bet. I'll send all of these out in an email after this session. Of course, I meant to ask if we could stop. If we could make the animation stop when y equals 0. Not directly, in that time is just going to move forward, time marches on. But if you did a little bit of algebra to figure out at which time that occurs, then you could plug that in for your max value at here. And let's see if we're right. So you can, but not directly. And so when does that happen, right? So if you solve this equation for when this is 0, that's going to be, yeah, it's a little complicated, but you could. I would do that by hand and plug in the value here. Can you explain again how you got the how I got our little projectile to make the path? So if not the parametric version, which part of the path would you like to re-explain? Or would you like me to explain again?
It was just on line 17 for you. How do I make that into an equation that's going to graph real time?
So you need your x and y to be functions of time. So you need to write this x1 of t, y1 of t, and then you plot that as an ordered pair. And you say, I want the parameter to run from 0 up through whatever the max value on my time slider is. Is that the question you're asking? I'm not sure if I answered your question or not.
I'll give it a try.
Okay. Yeah, this last line here is what gives the path. This is what actually plots it right here, is what's in blue. Now I'll add some notes to give things some context. Plot a single point at x1 comma y1 evaluated at time t0 is what happens here. Add a note below that. These are your projections onto x and y axes. And this last bit is plot the curve from time t equals 0 to time t equals t naught. On line 17, so this point right here, I'm showing two different ways to do the same thing. So I could just as easily do y1 of t naught, but what this does is say go up to point P, which is on line 15, and then dot y says grab the y coordinate of point P. So that's what the dot means. So P means go to point P, dot y means grab the y coordinate from that point.
How do you input that dot? Is that not
It's a period.
Oh, just a period. Okay,
Yeah.
thank you.
All right, other questions? Or other things you'd like to scroll up and see? Other things that you want to hear re-explained?
Can you just scroll up? I got a little lost when you started moving from T to T0. Did you define what T0 was at some point?
Yeah, T0, I renamed the slider T0.
Oh, okay.
So T0 is the specific time that the slider is at, and then T is now general time.
Okay, so that then you redefined X1 and Y1 with
to be variables of time.
Okay.
And then down here, I plug in the specific slider value into that general function of time.
Okay, yeah, that's the part where I got lost.
Yeah, the T0 is now the specific value of time. And then T is, I'm going to plug in a value of time into that function.
Can you scroll down just a tiny bit more so I can see how you plotted the curve?
You bet.
So that just looks like almost exactly the same as the P equals equation. It just doesn't have the P equals in front of it.
That's right. And the difference there, or the difference between them is T0 is one number. And so we're plotting the one number T0 in here. And then here we're plotting all values T between 0 and T0. So that's the difference between 15 and 20.
Thanks.
But otherwise, yes, they're nearly identical. Are T and T0 ever different? They are different types of things. T0 is a number, whereas T is a variable, is the difference here. So T0 represents a specific value, whereas in line 20 here, T represents all values between 0 and T0. So T is a range of things, yeah, and T0 is just one number. Other questions? Keep them coming. Happy to re-explain stuff. we're all at different places and we're all trying to recreate, and yeah, happy to say things again.
I'm sorry, can you explain line 20 again? Because I'm trying to do it and
I can, but what I'm going to do first is at the top, we're going to make T0, I don't know, 4.
Okay.
And so T0 is the number 4 right now. And line 20 is saying, for values of T that lie between 0 and 4, plot all x1 of T and y1 of T. So plug in all numbers 0 through 4 into x and y. And that gives you this curve that runs from 0 to 4. And so T is the variable that exists in these equations. And we're plugging in all values of T between 0 and 4 to make the blue parabolic curve.
Okay.
We're doing that for x and y points.
All right, I thought I had copied exactly what you did, but I'm getting an error message. I'll keep playing.
Yeah, did you, as your slider at the top, did you rename that T0?
I actually left it as T0 and then used a different variable for my functions.
Gotcha. That may be it though. I'm not sure how happy Desmos is to do parametric equations for things that aren't T.
Okay.
I think there's got to be T specifically as your parameter there.
Okay, I'll fix that.
For all values of T, what steps does it use? Whatever steps Desmos uses anytime it's making a graph. I don't know. It's going to make a smooth curve from 0 to 4. Yeah, so it's not finite points. It's making a smooth curve there, as much as a computer can make a smooth curve. Let's see, thanks for that quadratic equation function. Is there a way to do plus and minus, or it can only return one value at a time? Which values are you looking for? The solutions to the y1 of t equation?
No, it was the one that Mr. Almeida, I'm sorry, I didn't get your first name.
Okay,
He
I gotcha.
posted an image link of it. And I figured it out on Mac, it's Shift Option plus sign. I don't know what it is on Windows.
All right.
For plus minus.
I'm gonna go ahead. I don't know why I didn't think to do this before right now, but I could just send the link to this in the chat right now too, so you have my version of it there. All right. Before moving on to simple harmonic motion, which is the last one I for sure want to get to, because I think things moving back and forth is a useful general tool to have. I want to recap some of the reasoning and thought processes behind what we have here for our projectile, so that it can be generalized to other things that you may want to create. So as always, step one is a slider to represent time. We're now calling it T0 because we're going to use T to make the blue curve that's there. But T0 is how we move our animation
drive toward Herman Lake Drive.
Forward and backward in time. We got someone with a GPS and their mic on right now also, just FYI. And we made some parameters. We didn't change these parameters much, but I totally could change the initial launch angle, which you see lowers it. We can make our initial launch angle negative and throw it downwards. So we can do that, we could have changed our initial height. We could change our initial speed. We can see how those initial parameters change things. We could change the planet we're on, all sorts of fun stuff. Once we had that, we said, I know my X and Y motion is independent, so let's find components. I want to write equations of motion that are just functions of time t. I'm choosing to do that because I know I'll be graphing the parametric equation later. My projectile, I want to go to the specific value that those equations of motion take on at the present time, t0. So that's what this line does. And then I also want to see the past. And so I'm going to go also plot everything from 0 up to the present time, t0. And we also projected on the X and Y axes by making either the Y coordinate or X coordinate 0. So that is the quick summary of the thought process there. We want to set up time, set up the equations of motion that describe how this particle moves, and then we're in business. One more pause for questions, then we'll do a simple harmonic motion together. All right, let's save this and do a simple harmonic motion. Harmonic motion. So simple harmonic motion only happens in one dimension. So we only need one letter. What are the, well, we need a time slider. Let's call it T0 from the offset so that we don't have any issues there. And I want time to start at 0. I want it to end at, I don't know, let's say 10 for now. We'll have some initial parameters for simple harmonic motion too. Let's see, what are those parameters for simple harmonic motion? We'll have an amplitude. So let's call it A, and maybe its amplitude is 7. We will have a frequency, F, and maybe the frequency will start at 10 hertz. I want my frequency to be a number between 0 and, we'll say, 100. Amplitude can be negative, right? We can start on the left or right, and that'll help us out there. What else do we have? An initial phase. So we'll call that phi, and maybe the offset, oh, let's make it 0 degrees, but it could be something else. And this could be any number between 0 and 360. And I again want to go into degree mode for that. And those are the parameters that define simple harmonic motion, right? An amplitude, a frequency, and a phase. And let's do, I don't know, a vertical oscillator. It doesn't matter a whole lot, but let's do a vertical oscillator, something that's going up and down. We can, what's our equation of motion, right? That's what we need next. So equation of motion is going to be y1 of t, so of general time, is equal to a sine of 2 pi, I typed in pi to get the pi, f plus phi, close parentheses. And that, oh, I need a t in there, frequency times time. And I need the time, yep, so that's our overall, this is the graph of position versus time for our oscillator. I'm seeing a comment in the chat that you need to select degrees for every new activity or every new page. Yes, that is correct. Everything will default to radians to begin with. So you do have to select degrees every time. So this is our position time data for our oscillator. It's this nice sine curve, but I don't want to look at it. So I want to watch it move forward in time. I don't want to see all of the positions plotted against all possible times. And to do that, I need a point P equals. I'm going to go ahead and put this one at x equals 0. So 0, comma, y1 of t0. And we can see my point starts there at the origin, as it should, because we've got a sine curve. To make this cosine, it would start at the amplitude instead, which is up at 7. I'll go ahead and turn it back to sine. And that should be enough to get this particle to oscillate. If I press play, it goes up and down and up and down and up and down, and it'll do that forever. I'll leave this here. There's a few reasons I want to do simple harmonic motion, though, that I want to add to make this prettier. But the principles are there. I know that the equation of motion is a sine function, which has an amplitude, frequency, and phase. And then I know I want to plot it at position 0 for x and its y coordinate to be that y function evaluated at whatever my time slider t0 is. And if you press play, you should watch it. Should be able to watch it go. Question, can we animate the curve to move in the x direction? Yeah, you totally could. We'll hold off on that, but yes, we could do that. We definitely could. All right. What are some principles to talk about now? First thing I'd like to talk about is if you're going to have an animation repeat, which you often do want to do. You can make the motion look very smooth. The way we're going to do that is we're going to compute the period as 1 over the frequency. And then we're going to have our animation run from 0 to t. So it's going to go just through one full period rather than stop at some random time. Let's have the animation stop when it's done through one full cycle. Or you could do 2t or 3t or 4t if you wanted to go through a few times. Maybe we'll have to go through 5t. Maybe we go through 5 full cycles before we end it. If this is how you're going to approach it, I also recommend changing your animation properties from loop forwards and backwards to just repeat in one direction. So we don't want things to run backwards in time. I'm going to slow down my animation a bit, but if we put all this together, when we press play, that's too slow. All right. We have this go back and forth. Oh, it's going up. Why didn't that work?
Do you need to go to
about the period? We're in degrees. Oh, that is the problem, isn't it? So that is the problem. Bummer. All right. It wins. We'll do, never mind. But yeah, that is the problem. Shoot. Oh, well. So we could, if we go back into radian mode, everything will be happy again. That means we're going to change our phase constant to run from 0 to 2 pi. But now everything should be happy. This should go through 5 full cycles now. 1, 2, 3, 4, 5. And you see it's a smooth transition from there. Let's slow it down now. That's what I expected. Okay. So this will do 5 full cycles. And when you see the time slider get to the end, the motion will remain smooth because we're going through 5 full cycles before we end. To make that work nicely, we did have to be in radian mode. That's right. All right. Some other things I want to add, and the real reason I want to do this is I want to add a spring to make it look more realistic, and I want to turn my particle into a box so it looks more like the masses you might see in the classroom. Questions on just getting our particle to go back and forth in simple harmonic motion before adding those pieces in? All right, not seeing any questions. Then with springs, my one major recommendation is don't draw them. Because if you've ever tried to draw a coil on a computer, it's a pain to do. Find yourself a spring online, a nice spring image that you can do. So for example, I'm going to go search spring coil clip art. And you do need the word coil there, otherwise it'll give you pictures of bunnies and flowers in the season of spring. But find one you like. I don't know which one I like. I think I like this one. I'm going to open it up in a new image. Let's see. There we go, all sorts of options. I'm going to recommend that you grab a screen grab this time. And so if you grab the snip and sketch tool, if you're on a Windows machine, the reason I'm going to recommend that is you want the image, oh, if that was bad. You want the image though that just doesn't have any border to it for what we're about to do. So you want it just to be the spring, minimal border as possible. So grab yourself that screen grab, save it as your spring. Spring 3. Once you have your favorite spring image with very minimal background, you can add it to your animation with add image. And I put that one in the pictures folder. Where is my spring? I grabbed this one earlier. I like that one better. All right. So you get yourself a spring image. And there's ways to remove the background. Thank you, Kate. I appreciate that. Now, we want our spring to bounce. And to get it to bounce, we're going to look at everything that's here. So first of all, I need to shift this spring so that one end of it is along the x-axis. To do that, I need to raise it up. How much do I raise it? If I raise it a value y, y1 of t0, that doesn't do it. Let's see. I raise it a over 2, that doesn't do it either. But we want to raise it so that this bottom of our spring is higher up. And the height will, actually let's do the height first. The width, make it whatever you want, because that's not going to change. The height, though, should be y1 of t0. That should be however tall it is. your height should be, your height doesn't need to be a number, or it could be p dot y. I even like p dot y better. Micah, thanks for suggesting that. P dot y is your height.
Don't you want to multiply it by the original height just so that it
So we're not done yet. If we press play, we're going to see that it stays at the center, but we do see that it stretches out along with the particle. So we're getting there.
Okay.
But what we need to do next is shift this picture, the springs picture, up to meet the particle. And so we need to, I believe it's p dot y over 2 that does it for us. I had this earlier, I can look it up. That's right. So if you do the y coordinate of your position P and place that as a shift of the center, because we want to shift it up, we want to shift the center up halfway. That's why it's p dot y over 2. And so you can move the center along that y coordinate or halfway, and you want the height of it to be p dot y. And you put both of those together, your spring should oscillate. If we press play, should move along with your particle. So when animating pictures, this is, I found a very useful thing to keep in mind, a very useful tool is that you can change the height as a function of time and the position of the center as a function of time. And so if you make those the correct changes in height and center, you can have it match up with how the particle is moving. And this helps relate it back to the pictures that your students see.
Thank you.
Now, the next thing I'd like to do is turn our particle into a box. But before we do that, are there any questions I can answer? In what ways can I be helpful at this stage?
I got a little distracted when you were figuring out how to get this to repeat.
Yes.
How did you do that? Can you just quickly run through that, please?
I sure can. So I know that frequency, or the period, the time for one complete oscillation is 1 over the frequency. So I computed that. And then I chose then to run my time slider from 0 up through 5 periods. So it's going to go through 5 oscillations before it repeats. And it wasn't working at first. And the reason was because we were in degree mode. And so our sine function wasn't playing nicely. And so in order for it to repeat nicely, you will need to go back to radian mode.
Got it. Thanks.
Yeah, you bet.
And can you explain what the dot does again? What that function does, the p dot y?
I can. It means go to my point P, which is my green point up here, and grab just the y coordinate of it. And so p dot y is the y coordinate of point P. So I want my spring to have the height of that y coordinate, and then the center should be halfway from the origin to that height. All right, other questions? So as Bree pointed out, I guess I didn't wait long enough for questions. Let's do a little bit more wait time there. All right, so as Bree pointed out, you could make your mass at the end of this an image, and then you move the center along at this point P, And so you can do a pumpkin if you want, but I'm going to show you how to make a box or a shape in Desmos in case you want to do that. The Polygon tool is incredibly useful. And so then there's the question, how do we make it so just the bottom moves? So those are the two things we're going to do. That's a great question. I want to first change our particle into a box, and then I want to make it so that our spring doesn't invert across the x-axis. So those are the two fixes we want to make. Both of them are simple. Well, actually, let's go ahead. We can change the spring first. That one's the easier of the two. And the way we can do that is just shift our position function higher than the amplitude. So if our amplitude is 7 and we add maybe 9 to this and then drag our graph so we see it, now 9, the biggest this will ever get is to -7. So 9 minus 7 is still +2, and our spring is going to stay above the x-axis the whole time. So all you need to do there is add in a vertical shift that's larger than your amplitude. And now if we press play on this, our spring should look more realistic. And all we had to do to make that happen is add in a vertical shift to our equation of motion so that the y value always stays positive. So we just need a vertical shift that is larger than the amplitude value. And so 9 is hardwired to be bigger than the amplitude, but you could also do something like this, where, as Bree was exactly suggesting, you always make it something like a+1, so it's always 1 bigger than the amplitude. Or let me pause my timer. I'm going to recommend, oh, don't want that, come back. So yeah, 1 bigger than the amplitude. You could always do something like 1.2a also, so it's always 20% bigger than the amplitude. And now this way, no matter what, we've got a vertical shift that will always be a little bit bigger than the amplitude value. And that should give us an oscillation that's more realistic there. And if you want to oscillate down rather than up, totally a thing you can do. Just shift this plus to a minus. And then everything will happen below the axis instead of above it. So if you want it to be upside down, just have that vertical shift be a negative vertical shift instead of positive. So you can do either way. We'll leave it here. The last thing I want to show you, and it's because it's a useful tool with a lot of general applications, is the Polygon Tool. Polygon Tool allows you to make a polygon. You define the vertices, the vertices of your polygon, and you can make it. So for example, if I want to make, let's ignore the oscillator for a second. If I want to make a box in this corner of the origin, all I need to do is say polygon, write out the word polygon, polygon, P-O-L-Y-G-O-N, and then type in 4 ordered pairs. You use square brackets and then your ordered pairs. So maybe I wanted 0, 0 is one corner, 0, 1 is the next corner, 1, 1 is the next corner, and then, which one am I missing? 1, 0, 1, 0, close parenthesis, close square. I was unhappy. Why are you unhappy? Polygon is a function, so it is parentheses. Okay, there we go. So it is parentheses. I lied. I apologize for that. So if you want to make a polygon, you just type in your ordered pairs and you'll make a box. And now we want our box to move with time. So we can't just choose 4 random points. We got to choose 4 points related to the height of our box. So I'm going to go ahead and I think I'm actually going to make a folder just called box. So all parts of the box will live in that folder. How long do we want the side length to be? We made the width of the spring 3. Let's make the length of the box also 3. And I want my corners of the box to be at the following points. I'm going to make a list called C for corners. And the list will be square brackets. The 4 corners that I want are, let's see, we'll go to negative L over 2 for the X coordinate, Y negative L over 2. That's going to shift me to the left 1.5 units. So it'll be right where this edge of the spring's at. And the Y coordinate for that point, I want to be whatever your height is. So P dot Y. So that's going to be one corner of our box. It's going to be shifted to the left half of the length of the box, and its Y coordinate is going to be whatever the height is. Next corner of my box. It's going to look similar, but I want it to be halfway to the right, L over 2, comma, P dot Y again, because I want the vertical coordinate to be right at the height of the spring. So these are the 2 corners of my box that I've made so far. My third corner for my box is going to be still at the X coordinate plus L over 2. But now let's think about the Y coordinate. I need to go to P dot Y. And then I want to go down 1 box length more than that. So subtract off 1 additional box length. So my box will be a square. So this coordinate that's here, that's highlighted right now, says go half the length of the spring, go to the height of the spring, and then go down an additional box length. If you kept your spring upright, this should be a plus and not a minus, because you want to go up an additional height rather than down. And my last coordinate of the box, I want you to think for yourself for a moment, what will that coordinate be? That coordinate's going to be halfway to the left, minus L over 2, comma, we're going to go to the Y coordinate P dot Y, and we're going to go down an additional length L. And we have our 4 corners of our box now. And I'm going to close my list with a square bracket. So I've made a box by visualizing, by thinking about where I want these 4 corners to be. And I knew that since I'm changing in the Y direction, I would need to use the Y height to get to that height. And then I needed to go an additional length for 2 of my corners. And now that I have a square bracketed list of 4 ordered pairs, all I need to say is polygon, oh, not capital P, that's why it's mad. Polygon of C for my corners, and it'll make me a nice box with those 4 corners. If I want to turn off the red ordered pairs, just have the box, I can. And when I go up to my time slider and press play, my little box is going to go up and down. So I'll leave as much of this on the screen as I can. Actually, I am done adding things, I think. I want to turn off the simple harmonic motion particle. And I want to turn off the grid. Now that I've done that, I feel good about this. I will share this with the group. So some recaps of what we're seeing in this animation here is, and some of the reasons I wanted to do it is you can change the dimensions of an image dynamically. That's what we're doing with the spring image here. So we're changing both the height and the location of the center of our image as functions of time, according to wherever the simple harmonic motion particle is. And we can draw in shapes like polygons by creating lists of ordered pairs and then saying polygon of that list will give me that shape. If you want to do a line segment between 2 points, you can do a polygon that just has 2 vertices and it'll draw a line segment between those 2 points. Sometimes that line segment drawing is helpful too. Can you do vectors and arrows? No, you can't. And it makes me sad. Here's the best we can do. Let me pause my animation. I'm going to draw in what I'm going to call a displacement vector for our block. I'm even going to put in a note that this is the displacement, I'm going to put in quotes vector, because it's just going to be a line segment. There won't be an arrow. But if I drew a polygon from 0, 0 to 0, comma, p dot y, this green that's here, let me turn off the spring so you can see it better. This green is what the closest we're going to get to an arrow. Is this polygon is just a line segment that connects the origin 0, 0 to 0 dot p dot y. It only goes to the end of the block, and we can watch it move forward in time. But that's the best we're going to get, is this green segment that we're seeing here. Now, I have seen people be creative where they've drawn in additional little segments themselves. I've seen people add in images of arrows. So there are creative ways to add arrows, but there's not a default, this is a vector, which is a shame. But you could get creative if you wanted to with the arrow. You could do something like, see, we have a few extra minutes here. We could do another polygon that goes from 0 dot p dot y, which is the end of the other polygon we have, or the segment, comma. Let's see, if we shift p dot y, now if we shift things to the left, maybe negative 0.5, comma, p dot y plus 0.5. That's going to make this part of an arrow. So you can manually make in each little segment of your arrow. I could finish this off with another one that shifts this to the right like that. So you can make your own arrow, but you have to draw in each segment as its own polygon. Changing the frequency slider does not change the rate of animation. That is accurate, and it is unfortunate. Sometimes, yeah, so you do have to pay attention to that. I'll turn my spring back on. Yeah, so it changes. Yeah, the slider is going to go from beginning to end in a fixed amount of time. Is how that's going to work. All right, we've got 4 minutes left. I'm going to pause for questions. Why did I go to 5T instead of just T? Because I felt like it. And that's the only reason I have. You certainly could do one oscillation and be totally fine. Yeah, it wouldn't change what you viewed or what you saw. other thoughts, comments, questions,
Yeah,
hopes? Yeah, go ahead.
is it still in degrees or is it in radians? Just because you have pi's there, as in 2 pi.
I made mine into radians, and the reason I did that is because that would allow
For the frequency and that.
the frequency to play nicely with the sine function. Yep.
Okay.
Is there a preferred place to park sims that we create for others? I wish. I don't think so, though. I don't think anyone's made any sort of centralized spot for those. If anyone knows of one, please correct me, but I don't know of one.
Well, Helen Reynolds keeps that list, like a master list of all simulations. So you could tag her on Twitter.
Yeah, Helen Reynolds probably is the go-to there. God bless her and her organization. Like, what a lifesaver. It would be nice if there's a pretty good physics page for stuff like this. I agree. I tend to forget about pretty good physics sometimes, though, but it would be a good place for it. Yeah, Dan's got some amazing demos for sure. Friedman Physics has some great demos there as well. He's got a cool one with a cart that's accelerating that does use the iterative loop beta version, and it's pretty neat. So there's some great sims there for sure. All right, other thoughts for the good of the group? All right, not seeing any. So I'll reiterate my hope for this session. It's my hope that for those of you who have seen cool animations and wanted to try it out yourself, I hope that you feel you have the baseline you need to try things out. That is my goal, is that you've got the familiarity you need to try stuff out on your own. And so that's really what my hope is there. And share stuff with me. Let me know what you make. Like once you get into it and start getting a little more practice with it, it can be addictive. Like you definitely can really enjoy messing around and making some stuff for sure. And yeah, see someone say, John say you're gonna run down the rabbit hole for a while. Yeah, you definitely can. You totally can. You can make all sorts of fun stuff. And so and there's some requests in there for a uniform circular motion. I definitely can. I'll tell you what though, it's this simulation, but instead of 0 here for a point, you put in a cosine curve. And then you have simple harmonic motion, right? Because simple or uniform circular motion is just simple harmonic motion in both the x and y direction. So change out that 0 to a cosine curve and you've got your circle. But yeah, I can definitely share one. And I'll share all the links to these that I made. I'll send out an email in the next few days. That email will have video recordings, it will have simulations, it will have, once I create it, a feedback form for what you learned, what was helpful, what wasn't helpful, in case I want to do something like this in the future, ways that I can improve. So that's what I've got, folks. If you want to stick around and ask questions, I'll stick around for a few more minutes, but I want to respect your time. I know it's a Saturday in July, so go enjoy yourself for the rest of your day and have a wonderful rest of your day. Thank you so much for coming. I've had a lot of fun. I hope you did too, and I hope you've learned some things that will be helpful.
Thank you so much.
Yeah, you're very welcome.
Thank you. That was wonderful.
Yeah, thank you
so much, Joe.
Thank you. I really appreciated all this. This is fantastic.
I'm glad to hear it. I had a lot of fun. Thank you.
Thanks, Joe. Hey, are you willing to take a quick look at what I'm working on? Something's not working and it's bothering me.
I absolutely can. Give me just a second to find it there. It's in the activity builder?
Yeah, it's the simple harmonic motion one.
Let me pull that tab up.
You can probably look at mine specifically.
I sure can. That's why we did it this way.
Yeah. What I was trying to do, I was trying to create a curve that draws itself like we did with projectile motion. And I really felt like you can see down there, it's my line number 9, which
Hold
is
on, I'm still getting it pulled up here. Oh, that's why I couldn't find you, because I had the anonymous people on.
Yeah.
All right, let's see, Andrew. Let's see, somehow your response is not showing up for me for some reason.
Oh, that's
I wonder why that is. If you wanted to share your screen, you should be able to. Let me know. Oh, are you Andy, not Andrew there? Okay.
Andy B, sorry.
Yeah, that's why I was searching Andrew in my search bar. Okay, great. So your line number 9 is
the X1T0, Y1T0.
Yeah.
And for some reason, Desmos considers that a point, but when we did it with the projectile motion, Desmos considered that a curve.
Well, when we had the curve, we just put in T and not T0. So T0 is our specific value from our slider. But
so if I change these to T.
If you change those to T, now we're going to run into issues also is that we don't have an X1 of T defined anywhere right now. And in fact,
down there.
I think what you're going to want to do is make that first coordinate just T, right? Because we're plotting the position versus time. Let me double check that works. Yeah, so that does work. It makes an awful curve, but it does.
Oh, mine's not doing anything.
Let's see. You've got. Is that showing me any edits you made? Maybe I've got to refresh. Give me a second. T, Y1 of T. Oh, yours. Oh, and the reason it's not animated right now is right now you're plotting between 0 and 1. Oh. And you'll want to plot between 0 and T0. And so you'll want your bounds to be between 0, the beginning, and then T0, which is the time we're at right now in our animation.
Oh, now I see it is moving. Okay. All right.
Yeah, cool. Oh, that's nice. I like that. That looks really cool.
All right. Well, thanks, Joe. I really appreciate it. I will probably be like twittering with you here when I have questions. But,
yeah, please do. Absolutely.
I appreciate all you did. I was really looking forward to this. I've been playing around with Desmos for a lot, and I learned a few new things, and anxious to learn more, actually.
Awesome. Thanks so much.
All right. Bye-bye.
Have a good one.
Yep.
Actually, I do have a question.
Yeah, you bet.
All the work that we've done today, are we going to have access to this once, like, will I still be able to go back in and look at what I did and play with it and stuff?
Yep, you definitely should. And I have no plans of deleting this class for a while anyways. I mean, probably I'll keep it for at least a year, right? At least through this school year. If not forever. Like, I don't see any reason to delete the class. So you'll have it as long as my Google account exists and I keep it alive.
Awesome. Thank you. I do have one more question. Oh, go ahead.
I was gonna say the issue, Julie, is you won't be able to copy and paste whatever you created into your own activities.
Okay.
So that was where, and so I don't mind. I made mine separate. So everything that you just did, but I think yours are separate, right, Joe?
The ones that I made, yeah. That's right.
They're separate. Then you can paste it and put it in your own activity builder. But whatever you did in the activity, you can't easily get it out to put into your own activity builder.
Okay, I just wanted it to be around long enough so that I could redo it in my own folders.
Yes, it definitely will.
I do have another newbie question because prior to this day, all I've done is create an account. So on that teacher dashboard that you showed, how do I get there? Like, do I have to create a class first, right?
So yes, you either create a class or use a single session code, either for an activity. You can do either. And then once you're there, let me pull it up. So teacher.desmos.com. I'll share my screen again. You will go to classes.
Okay.
And then once you're under the classes tab, you can look at your assigned activities.
Okay.
And once you click on, then I can click on any of these and it'll take me to the dashboard for that page.
Okay. So I will have to populate, like I've got my list of students already. So I will populate a class with my students. And then I will be able to get to that blue dashboard thing that you had where you were adding files.
That is correct.
I can't even get there before I do this. Is that
So,
correct?
so if you're planning, there's a yes and no answer to your question.
Okay.
And so if you're planning on having your students sign up as a class on Desmos, they will need to register first, exactly as you said.
Okay.
If, however, you plan on using maybe one thing the whole year and it doesn't seem worth it to make a whole class and have them register, you can just do an activity with them without them being registered for a class. And to do that, you just go to your activities folder, click on whatever activity you want to do. Then when you assign it, instead of assigning to a class, you can get a single session code and choose how long that code will be active for. And then it just exists to look at. You can view the dashboard right from the activity.
Oh, okay. I understand. Thank you.
Yeah, so you can assign it to a class, or you can just do a single session. They don't have to register for anything. They just go to a link and do it for you.
Will I still be able to see all that nifty teacher side stuff you were showing us if I do the single
Correct.
code?
Yep.
Okay, because my school is way behind when it comes to that SOPA stuff. And they don't have Desmos on their list of approved sites. So the single code is the way to get around that.
Single code will mean that your students don't have to register with an email. They can just get in, put a name, and start going.
Awesome. Thank you.
You bet.
That's fantastic.
One thing.
Thank you very much.
Sorry, one thing about that, just because, yeah, if they sign in, like if they make an account through Desmos, then they can stop the activity and go back and pick up where they left off. If they don't sign in, they can still go back, but they have to start like another session. And then what I have done with my students is just said, just remember what slide you left off at.
Okay.
Problem if you have stuff that needs one slide to go to the next one.
All right. Okay. All right. Well, at least I have a workaround if the school says I can't have them sign up for stuff. So,
yeah.
All right. Thank you.
That said, though, if you submit to your whatever IT people that this is a site you want them to look at, and they eventually get around to it, which I know with a lot of school districts are two big ifs. But if you get there, Desmos does comply with all laws to make sure student privacy is protected. So it is a site that would be approved.
Okay. Excellent. Thank you.
Yep, you bet.
Thanks, Joe. Sorry, I was just sticking around because I like gleaning all the knowledge.
Oh yeah, you bet. No, Andrea, thank you so much. Thank you. You offered a lot of useful and helpful things for the group too, so I appreciate you jumping in with those things.
Thank you. And I just want to say, with the intro stuff, I learned there's stuff I didn't know. Like, I'm a big keyboard typer thing, and I didn't realize that you could just type table folder. That's awesome.
Great. Yeah.
I just learned you can type like X1 and it will do X sub 1 automatically. Yep. That's awesome.
All things that save you time for sure. And I'm with you. Like those little things that maybe save half a second, I love. Like for whatever reason, like, oh my gosh, my life gets so much better. I'm with you.
Do you have that simulation thing on the, because like I went in and it's like suddenly they have all these new things that I don't know if other people have, if they've tried it out.
Which simulation thing? It seems like some people had more new things that I didn't have.
Yeah. So I've been taking pictures. So obviously not in the activity builder, it's not there. But look under the what is it? Add things. So where it's like add folder expression, blah blah blah. There's also a thing for simulation.
Oh, I don't have that. No.
No. Yeah. There's also it doesn't seem to be.
You must be in whatever lucky group's getting some A/B testing to try stuff out.
I don't know why though, because I don't make a lot of simulation. I'm a little guilty. Then there's also like a settings thing, which looks awesome. And I'm really upset that they haven't enabled the shift enter new line, because I'm like, give me that one. There's a hotkey for duplicate expression.
Cool.
I don't know what it is. Find and replace, there's a video creator, you can pin expressions. Like I'm loving all of this stuff. So there's some stuff that may be coming down there. I'm just going to turn that off.
Nice. I'll be looking forward to that whenever it gets rolled out.
So I was hoping, yeah, the problem is I can't find any documentation about it.
Right.
Because I'm sort of like, how is this supposed to work? Because the simulation stuff, just add this in. It's on every update, set something to whatever animation speed, frames per second, then you can add an update rule. So I don't.
Yeah, the add update rules, that will be cool. I don't know how it works either because I don't have it, but I've seen people use it. But that will allow you to do things like write in an acceleration right from Newton's second law and then approximate the updated velocity to updated position, cycle back and do that over and over.
Yeah.
And there'll be some cool simulations we can make once that's a widely available tool.
So, okay, anyway, so I don't want to take it through to any more of your time. Thank you so much. Really appreciate it.
Yeah, you bet. Thanks for coming.
Thanks.
All right, have a good rest of your Saturday.
You too. Bye.